So now we have to discuss what a polynomial function is. So a polynomial function is really similar to a power function. However, it has more terms than just the leading term. So let's look at this general form right here. The a sub n represents the coefficient. In this example, it's the leading coefficient. X is our variable and n is our exponent, where n is a non-negative integer. That just means it's a positive number, or 0. That's all that means. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that, but it's also 0. So like in this last one, that would be like x to the 0 power right there. So look at this first example. Which of the following are polynomial functions? You just want to make sure that you can write your function as a string of terms like we have at the top. For example, this one, if you multiply the first two using order of operations, you get 6x to the 4th plus 4. Everything in here is real. The coefficients are real. The exponent is a real and a positive number. Integer, if you want to think of it that way. So this one is definitely a polynomial. How about the next one? We can distribute. We get negative x cubed plus 4x. This is also written in polynomial form, where the coefficients are real, the exponent is a positive integer. So then we get to this last one. We could actually rewrite this using exponents, but we get this as our function. First of all, this is not a positive integer. That right there tells you this one is not, and the first two are. So what is the terminology for polynomial functions? When you list your polynomial in descending order, meaning the exponents decrease. So like if this was a cubed function, it would be x cubed plus x squared plus x plus 1, something like that. Your exponents decrease as you read left to right. Your leading coefficient is the number in the front of your highest exponent. Okay, the degree of your polynomial is that highest exponent, and that whole first term is called your leading term. So in the following examples, we want to identify the degree, the leading term, and the leading coefficient. First, you want to rewrite them. This is the same thing as negative 4x cubed plus 2x squared plus 3 if you write it in descending order. So the degree is the highest exponent. The leading term is negative 4x cubed. And the leading coefficient is negative 4. So then let's look at the next one. This one is written in descending order already, 5, 3, 1. So we can just answer the questions. The degree is degree 5. The leading term is 5t to the 5th power. And the leading coefficient is a positive 5. The next one we need to rewrite into descending order. That's negative p cubed plus 6p minus 2. The degree of this polynomial is 3. The leading term is negative p cubed, and the leading coefficient is negative 1. So in the last video, we talked about the end behavior of power functions. Remember, we said if it's an even powered power function, it makes a U shape, and if it's odd powered power function, it makes that S shape. Well, a polynomial works the same way. The difference is, if you have an even degreed polynomial, it still goes up on the ends or even down on the ends, but it could do crazy stuff in the middle. For your odd function, it will still go down on the left, up on the right, or vice versa, but it could do crazy stuff in the middle. Here are just a few examples that we could talk about. Our leading term for this polynomial is 5x to the fourth. So you can see that this graph is parabolic in shape, but look what happens right here in the middle. It does something a little bit different than a parabola would do. So you can still say it goes up on the left, up on the right, or as x gets bigger, y gets bigger. As x gets smaller, y gets bigger. You can still say that. Just know that it's even powered and it still makes that parabolic shape with crazy stuff going on in the middle. So what about the next one? Negative 2x to the sixth is also even powered, but since it's negative, it's flipped upside down. So it's this direction, but you can see that it does something kind of crazy in the middle. Okay, the next one is an odd powered function. Odd powered is S-shaped. So you can see this one is definitely S-shaped, but it's doing some crazy things in the middle. By the way, I copied these straight out of your textbook. If you need to see them, I don't remember the page number. Oh, it's page 366. And then our next one is